In the previous outlines, we defined the trigonometric ratios for acute angles. Here we extend the trigonometric ratios to all angles by defining the trigonometric functions of an angle. Trigonometric functions are a family of 6 functions: sine, cosine, tangent, cosecant, secant, and cotangent. Their input values are angles, and their output values are defined below. Let theta be an angle in standard position, and let P be the point with coordinates x, y, be a point on the terminal side. Lowercase r is equal to the square root of x squared plus y squared, and that is the distance from the origin to the point P with coordinates x, y. We can see a picture here down below where we have an angle theta, and the terminal side of theta is in quadrant 2. Note that the input could be a positive real number or a negative real number. So it's positive when our angle rotates in the counterclockwise direction, and our input value theta is an angle that is negative if we rotate in the clockwise direction. This also goes for the output and the sign depending on the quadrant that the angle falls in. So what I mean by that is, if you look at this angle theta, we have that our terminal side ends in quadrant 2. And so to get to this terminal point here, since we're moving in the left direction, x here is a negative number. And in order to get to our terminal point, we move up, so that means that y is a positive number. Now, that could be different. Let's say that we had an angle that ended us up in quadrant 4. And so this would have different coordinates. And since we're moving right, our x coordinate here would be positive. And our y coordinate, since we're moving down, that would be negative. And so this is all for if our angle ends us up in quadrant 4. Since division by 0 is an undefined operation, some of the trigonometric functions are not defined for certain real numbers. Because of this, we need to determine their domains. So here we have laid out our 6 trig functions. Let's talk about their domains. So when we are talking about sine and cosine, the domain is going to be all real numbers. And that is because if you think about an angle, it's always going to have an associated point on the unit circle, and that point is always going to have an x value and a y value. So we can plug in any angle into our sine or cosine function and get an output. Let's talk about tangent and secant. So if we wrote out some of the identities for tangent, so tangent of theta is equal to sine of theta divided by cosine of theta, and secant of theta is equal to 1 over cosine of theta. Now, the domain is going to be all real numbers except for the values that are going to make cosine equal to 0, because notice that both of these have cosine of theta equaling 0, or cosine of theta in the denominator. And so if you think about the unit circle, the places where cosine is equal to 0 are at the top and at the bottom. And so the first time around, if we go and we end up at the very top of our unit circle, that angle is pi over 2. And then if we go to the bottom of the circle, then that full rotation would be 3 pi over 2. And we can keep on rotating around the circle, and it turns out that whenever you have an odd multiple of pi over 2, then the function ends up being undefined. So for tangent and secant, the domain is all real numbers other than pi over 2 plus n pi for any integer n. So again, to reiterate, our domain is going to include everything except things like pi over 2, 3 pi over 2, 5 pi over 2, and we can go in the negative direction as well. So negative pi over 2, negative 3 pi over 2. All of these values are excluded from the domain here. Anything else is going to be fair game. Let's write out the identities now for cotangent and cosecant. So cotangent of theta is equal to cosine of theta over sine of theta, and cosecant of theta is equal to 1 over sine of theta. So for these, we have to be concerned with the values of theta that are going to make sine equal to 0. So let's draw our unit circle again. And the places that sine is equal to 0 are here, the left and rightmost points on the unit circle. And so this angle is 0. This angle is pi, and then if I wrap around and go back, this will be 2 pi, and then if I wrap again, then this will be 3 pi, and so on and so forth. So for cotangent and cosecant, our domain is all real numbers other than n pi for any integer n. So basically, integer multiples of pi are excluded from our domain, so pi, 2 pi, 3 pi, 4 pi, and I could go in the other direction, negative pi, negative 2 pi. These are all excluded from our domain, but everything else is fair game. So that concludes talking about the domain of each of the 6 trigonometric functions.